Welcome to Fresh Thinking by Snowden Optiro. My name is Susan Havlin. I'm Managing Consultant for the Geology team in Perth. We're joined today by Tarrant Elkington, our General Manager. Welcome, Tarrant.
Thanks. Glad to be here.
So this is our sixth episode of 7 in a series that we've been talking about. So in the previous episodes, we've discussed how simulation best approaches such as local conditional simulation or LCS can provide a more consistent framework for analysing uncertainty in mineral resource models. So in this episode, we're going to shift our focus to the mine planning implication of these models. So ultimately, the value of any resource model lies in how well it supports mining decisions. So the question becomes, how does a model that better represents grade variability, such as an LCS model, influence the way deposits are evaluated and mined? So let's start with the basics. Why is the resource model so important for mine planning?
Well, I guess we've been over it on a few podcasts, but the resource model underpins the whole mine planning process and economic evaluation. So what you mine, what grades you're going to get out of the ground, what productive capacity that you should be choosing to adopt for the mine, and ultimately whether the whole thing's economic. So that it's the absolute most fundamental part of the whole mine planning and project evaluation process.
And so how we represent the grade variability is actually in a resource model is really important for mine planning.
Yes, absolutely, because depending on which cutoff grade you apply, you get a different number of tons in grade. And if the resource model reflects reality or doesn't reflect reality, will ultimately swing the whole pendulum, and sometimes by values by 20%, 30% of the total project value. So it's a pretty critical thing.
So earlier in the series, we discussed the smoothing effects associated with conventional estimation methods such as Ordinary Kriging. So how can that influence mine planning decisions?
Well, depending on what cutoff grade you use, smoothing might give you a different version of how many tons you'll get out at, say, a higher cutoff grade. And lots of people or lots of mines are operating on grade streaming approaches where they try to maximize their grade, stockpile low grades. So it's not just about trying to estimate what's the total amount that's going to get mined, but also the total amount that you're going to get in certain grade bins to be able to get more accurate production forecasts. So, if there's smoothing where it's appropriate and necessary, or there's over smoothing, it's like most things, there's a balance of what you're trying to achieve. If there's too much smoothing, you might end up making different mine planning and economic evaluation decisions.
And I'm presuming the way the current climate is with such a high gold price, the actual cutoff grade and the fact that we've mined most of the high grade deposits, we're looking at lower grade deposits.
Yeah,
at the moment.
Yeah, the whole definition of what high grade shifts down a little bit when the price is so high, and we've depleted a lot of the high grade deposit, but it's still the same. They still get a distribution, and and it's quite important. If your domain has a lot of waste and it's smooth, then you might want to be able to isolate the higher portion of it. So.
Yeah. So when a model is built using localized conditional simulation or LCS, what differences do mine planners typically see?
Well, I guess firstly, it's got a different grade tonnage characteristic maybe than a ordinary Krieg estimate or more traditional estimate. But that's just like any recoverable resource estimate. You're trying to reflect what the grade bins and grade distributions going to be. So that's really the main change, is that they've got grade tonnage curve. Everything else, most of the other processes stay the same.
Okay. So typically when new modelling approaches are introduced, people often ask whether they fit within existing industry workflows. So in your opinion, can LCS models be used in the same way as conventional resource models?
Yeah, and that's an important point, that LCS is a localized model, a localized recoverable resource estimate, just like any other recoverable resource estimate. So you think about, people probably heard of localized multiple indicator kriging, local uniform conditioning. The model presents in the same format and way. So from that point, you can go on and do all of your standard mine planning processes just in the same way you would do that. Additionally, it appears in the same format as ordinary Krieg estimate would. So for a mine planner, it's actually the workflow is actually very similar and familiar as a result of this.
So how does this connect back to the recoverable resources concept we discussed earlier in the series?
Well, a recoverable resource is trying to estimate the grade variability that you might get at a mining scale rather than at the exploration data scale. So we're trying to sort of project that change of
Mm-hmm.
that change of support. So um, I guess that connects it to where the mining scale is, and ultimately we're going to go and do the grade control drilling and hopefully be able to define the resource to that level of accuracy once we get there and do the grade control drilling. So at the end of the day, it comes down to whether LCS provides the best representation of the potential presentation of the ore body upon a grade control level as a local MIK, local UC model.
Okay. So, are there any operational implications when models preserve this grade variability?
Yeah, I think the most important thing is around dilution and ore loss, because the smoothing that occurs in a more traditional model or an ordinary Krieg model actually mimics some of the mixing processes that we see in dilution. So it imposes some continuity and pushes you to a more bulk orientation. A recoverable resource estimate, you'll see a lot more grade variability, sort of spotty grades, which is kind of how the data probably is. But it also means that when you come to mine it, we need to consider whether we could actually mine the shapes that are being presented by those models. So a recoverable resource estimate might present with a certain number of tons and grade in the resource level, but when you go to then apply dilution or mining shapes to it, might have the need for additional dilution and ore loss to be considered relative to an ordinary Krieg estimate. That, to me, that's the whole crux of that of the difference between like any recoverable resource estimate. This also applies to LMIK, LUC.
Okay, so earlier in the series, we discussed how simulation can be used to analyze uncertainty and risk. Does using an LCS model change how simulation might be used in mine planning?
Absolutely. And that's one of the really great parts of LCS, is that it's backed up by the conditional simulation work itself. So lots of people have been interested. We had other presentations on stochastic mine planning, where we use conditional simulation for mine planning to develop more risk-aware mine plans. And for me, one of the main issues with mining engineers using it, firstly, is the availability of software to do it, which there's tools that are being developed that we've talked about. But the other part is actually making conditional simulation part of the mainstream. If we can't use conditional simulations to declare reserves, then it's more of an academic process. So now we're talking about using LCS for reporting of resources that could potentially be used LCS to develop a reserve. It then becomes much more relevant to go and do sensitivity analyses using the conditional simulation data, stochastic mine planning used to the data. It opens up a whole world of these things that you could explore, not just as a side parallel academic process, but something that's actually going to be like implemented, that you can reconcile against, and that you can test sensitivity. So I think that's a really exciting potential for the method that you don't get out of the other resource estimation methodologies.
Throughout the series, we've discussed the concepts behind recoverable resources simulation and localized conditional simulation. So in the next and final episode, we'll look at how these ideas have been applied in practice through a case study from the Bullabulling Gold Project, where LCS was used to better understand the deposit and support project evaluation. So in this episode, we've explored the mine planning implications of simulation-based resource models, including how LCS can be integrated into the mainstream mine planning workflows and support ore reserve estimation. We've also discussed how models that preserve realistic grade variability highlight the importance of carefully considering dilution, ore loss, and mining selectivity. In the final episode, we'll look at a real-world example of how these concepts have been applied in practice. So thanks for joining us, Tarrant.
Thanks for having me.
Thank you for listening to this episode of Fresh Thinking by Snowden Optiro. If you've enjoyed this episode, please subscribe. If you'd like to listen to more, it can be found where all good podcasts are found or on our YouTube channel.